Rapid Spanning Tree Protocol. The original Spanning Tree Protocol 802.1d was defined in 1998. This protocol conversion time is very slow. Rapid Spanning Tree Protocol 802.1w was introduced after that to fix this problem. We will describe the characteristics associated with the RSTP, also configure RSTP parameters. Since STP uses the timer techniques, so it has a very slow network topology conversion speed. RSTP uses a proposal and agreement process, which allows the immediately negotiate of links to take place. So since it doesn't use the timer techniques, it will make the network converged very fast. RSTP still has the support root role and the port designated role, but it adds two new roles for the port. One is called the backup, and one is called alternate. Alternate port represents a best backup path to the root bridge. Backup port instead represent a backup for the designated port. So alternate is the backup for the root. Backup is the backup for the designated. RSTP edge port. Edge port doesn't receive configuration BPDU. It is the network edge. It also doesn't participate in the RSTP calculation. It can change from disabled state to forwarding state without any delay. Port states of RSTP. STP has 5 states. RSTP only have 3 states: discarding, learning, and forwarding. So disabled port, alternate port, and the backup port, they are all discarding. Root and the designated port, under some condition, will be put into the discarding state. We will talk about this after this. Discarding port doesn't forward user traffic. It doesn't learn MAC address either. Learning will not forward user traffic, but it will learn MAC address. Forwarding port will forward user traffic and also learn MAC address. Rapid Spanning Tree BPDU. In this BPDU, the Spanning Tree protocol only use 2 bits of these flags: topology change, acknowledgement, and also topology change. Only use these 2 bits. rapid spanning tree BPDU use all of these 8 bits. Here it is an example we captured by Wireshark. In this rapid spanning tree BPDU, you can see the first one is protocol identifier, protocol ID. This is the spanning tree protocol. Second one is protocol version identifier. It is 2, rapid spanning tree. BPDU type is a rapid multiple spanning tree. Flags, BPDU flags. So this one is agreement, forwarding, learning, designated port, topology change. So after that is the root ID. Root ID, here is the priority, that's the MAC address. Root pass cost. Root pass cost is 0 because this one is the root. Bridge ID. Bridge ID is same as the root ID because that's the root bridge. Port ID. Message edge. Max edge. Hello timer. And the forward delay. So port row 01 is alternate or backup port. 10 is root port. 11 is designated port. There are 2 bits for the port row. In STP, after the topology became stable, only the root bridge sent configuration BPDU at the interval of hello timer. The non-root bridge does not send configuration BPDU until it's received the configuration BPDU sent from the upstream device. In Rstp, after the topology became stable, the non-root bridge will send configuration BPDU at hello intervals, regardless whether it has received the configuration BPDU sent from the root bridge. So such operations are implemented on each device independently. Rstp convergency. All Rstp enabled switches begin as root. This is the same as the STP and send RST BPDU. The difference is all those ports are set to the designated row, but discarding state. Here is an example of this kind of package. So you see this port is designated port, but it's not in the forwarding and it's not in the learning. So basically it's discarding. RST BPDU proposal. Proposals are sent in RST BPDU during the root election. If a switch have a better bridge ID, it just ignore the proposal. Rstp synchronization process. This process is like a handshake. So root send the BPDU proposal. If the downstream receive the BPDU proposal, it will set all his designated port to discarding. And also the downstream switch will reply the proposal BPDU by sending his agreement bit and the port route bit to root. Root bridge, when it receives the reply, it will change the its own designated port into forwarding right away. So since it doesn't use the timer, so it will make the network generation much faster than the STP. RST BPDU agreement. Once all downstream no-edge designated ports have been blocked, switch B will send agreement with the RST BPDU. Here is a package we captured. You can see the root bridge is 0648 and the downstream switch basically is the switch 1297. So it will send agreement back to the root switch. From the package you can see the root port, and the interface has been determined to be the root port. So the root role field and the agreement flag, agreement bit in the flag will be assigned. Again, it's the agreement and the root. This is a response to the proposal BPDU. So basically, the root switch will send the proposal to say I'm the root. So the downstream switch, in this case, the switch B, will when it receive this and check the its priority is higher than switch B. So switch B will block all his designated port, for sure, except the end port. When it does that, it's basically reply to the switch A to say, okay, I agree, you are the root. Also, I put that port, this port, to the root role. And when switch A receive that, they say, okay, this guy already agree, I'm the root. So it will put this designated port to the forwarding before it is discarding. So this page basically displays what I just said. So the downstream port is again unlocked, and neuron synchronization occurs between B and C. Basically is from this switch to its downstream switch. In STP, a device has to wait max age by default 20 seconds before determining a negotiated failure. In Rstp, if a port doesn't receive configuration BPDUs, sent from the upstream device for 3 consecutive hello intervals. The communication between the local device and its pair fails, causing the proposal and the agreement process to be initiated in order to discover the port rules for the line segment, which basically means loss of the uplink as RST BPDO signaling, link device failure. So proposal and agreement based convergence will ensure it will modify, increase the network convergency. So before you have to wait about 20 seconds to start. Now it's much faster than before. Topology change process. During the sending of agreement, MAC addresses are flashed for all ports except the port on which the RST BPDO was received. Topology changes affect RSTP similar to the STP. However, there is some difference between two. So the basically it says, see the switch A and the switch C. This link went down. So the A and C will detect the link failure immediately and flash the address entries for ports connected to that link. So for this link, RST BPDO will begin to negotiate the port states as part of the proposal and agreement process, following which topology change notification will occur, together with the forwarding of the RST BPDO containing the agreement. This RST BPDO will have both the agreement bit and also the TC topology change bit set to 1 to tell the upstream that it need flash is MAC entries on all the port except the port interface on which the BPDO contain this TC topology change bit was received. Here is the example of that packets. You see the in these packets the topology change bit was set to 1, and also at the same time the agreement set to 1. Also, the TCP bit will be set in the periodically sent RST BPDO and forward upstream for a period, which is hello time, which by default is 2 seconds plus 1 second, basically it's 3 seconds, during which all relevant interface will be flashed and should proceed to repopulate the MAC entries based on the new RSTP topology. So here, this interface, all the MAC address will be flashed. STP interoperation means if some switch run STP and all the other switch run RSTP, basically all the switch run STP will still wait for 50 seconds before convergency can be completed. So we recommend that never use the STP and also Rstp in the same network. Here is the configuration of how to change the STP mode. Basically, STP on the Huawei switch, there are three options. One is MSTP, one is RSTP, and the other one is RTP. So this command basically is under the system view mode. It enables the switch to run RSTP, the whole switch. Configuration validation. So the command to display the STP status still the same command, display STP, even you see we run RSTP. Setting the edge port. So under the interface view, the command is STP edged port enable or disable. So this command will allow the edge port to forward traffic without any delay. So interface on the S5700 are non-edge ports by default. So basically you have to manually configure it if it is the edge port. So by default, edge interface defines a port that does not participate in the spanning tree topology. This interface should only be used by end systems. Edge port is designed for RSTP, but however, it says it is also possible to apply the RSTP edge port setting to STP within the Huawei SX serial products. So there's another way to configure the edge port. Under the system view, if you run this command, all the ports on the switch will be configured as edge port. In other words, if you want to connect those interface to another switch, you have to manually disable the edge port on those specific interfaces. So this is not a good way to configure the edge port. So we recommend you to first, the best practice is first you shut down all the interface on the switch, and you configure the enable the interfaces when you need to connect it to all the other devices, and configure edge port one by one when it is needed. BPDU protection. So by default, if the edge port, it shouldn't receive any BPDU, but if for some reason the edge port received a BPDU, it will change to non-edge port, which means it will calculate the spanning tree topology. So in order to defend against the pseudo BPDU attacks or any mistake, such as someone plugging a switch to the edge port, the Rstp provides a BPDU protection. If you enable this function globally on the switch, if you enable this function, the edge port was shut down if it's received BPDU. Loop protection. Loop protection should be configured under the interface. If BPDU failed to be received on the downstream switch, the root port is blocked to prevent a switching loop. So which means you should configure this function for the root port. So basically, after the loop protection function is enabled under the interface, under the root interface, if it cannot receive BPDU from the upstream switch, this port will be blocked, and it will remain in the block state and does not forward packets. This prevents loops on the network. So another caution is, if an interface is configured as an edge interface or root protection is enabled on that interface, loop protection cannot be enabled on that interface. You can validate the configuration under interface. So the command is display Rstp interface and interface name. So you can see the associate the parameters or status. You see this port is forwarding, protocol is enabled. This is the root port. The port priority is 128. The port cost is 20,000. Designate the port, the bridge, and the port. And the protection type is a loop protection. And the mode is Rstp. So, question: what is the purpose of sync that occurs during the Rstp proposal and agreement process? So, the sync is a stage in the convergency process that involved blocking of designated port while the RST BPDU was transmitted the containing proposal and agreement message to converge the switch segment. The process is designed to ensure that all interfaces are in agreement as to their port role in order to ensure that no switching loops will occur once the designated port to any downstream switch is unblocked. Thank you for listening.